Today we are going to talk about organic chemistry. In this video, we are going to talk about hydrocarbons and how to name and draw hydrocarbons. It is important for us to know that in organic chemistry, the most important element is carbon. So as we go forward, please make sure to download the packet from Google Classroom for organic chemistry and also make sure to have your reference table in front of you as we go forward with this video. We're going to talk about organic chemistry in terms of reference tables. So first we're going to talk about reference table P, and then we're going to talk about reference table Q in this video. The notes are already available in your packet. Organic prefixes are listed in reference table P. The prefixes are listed for the corresponding carbon groups. If a molecule contains 5 carbon, then the prefix would be pent. However, there is a slight change I would like you guys to make in your reference table P. Where it says number of carbon atoms, please add the term total. So by using the prefixes, we're going to understand the total number of carbon atoms in a molecule. I would highly recommend you guys to memorize these prefixes instead of just looking at reference table P. For example, if a compound has only 1 carbon, the prefix would be met. If a compound has 2 carbon, the prefix would be at. If a compound has 3 carbon, the prefix would be prop. If a compound has 4 carbon, the prefix is going to be but, not but, right? So keep that in mind as we go forward. Let's take a look at reference table Q. In reference table Q, we are going to learn about 3 different types of hydrocarbon. They're known as alkanes, alkenes, and alkynes. For alkane, we have saturated single bonds. This is important. We have saturated single bonds. So if you look at carbon-carbon bond, you'll see that there is a single bond between those 2 carbons. And the name ends with A and E, alkane. For alkene, the name ends with E and E, and we have a carbon-carbon double bond, and that is unsaturated. For alkyne, the name ends with Y and E, and we have carbon-carbon triple bond, which is also unsaturated. So in a hydrocarbon, we only have hydrogens and carbons. And saturated means you have maximum number of hydrogen with every carbon. So if a carbon is bonded with another carbon with a single bond, then rest of the 3 bonds can be utilized to add hydrogens. And that is why the general formula of alkane is CnH2n plus 2, meaning whatever the amount of carbon, the amount of hydrogen is going to be 2 more than double than the amount of carbon. And that's saturated amount, meaning the maximum amount of hydrogen in a hydrocarbon. For alkene, the name ends with E and E, and it's not saturated because there is a carbon-carbon double bond. So when you have a carbon-carbon double bond and you know that a carbon can only create 4 bonds in this case, and you are already using 2 bonds with another carbon, then you only have 2 more bonds to form a bond with hydrogens. If you compare alkane with alkene, you will realize that alkanes have more hydrogen attached with the carbon compared to alkene. You can also look at the general formula where alkene has a general formula of CnH2n, meaning the amount of hydrogen is exactly double than the amount of carbon, where alkane had more than double amount of hydrogen for each carbon. And this is why alkene is unsaturated, meaning it does not have the maximum amount of hydrogen attached to a carbon. Same goes for alkyne. The name ends with YNE, where we have carbon-carbon triple bond. So out of 4 bonds, if carbon is using 3 bonds to attach with another carbon, then it only left out with only 1 bond for hydrogen. Clearly, you cannot have the maximum amount of hydrogen that we usually have in an alkane. And therefore, alkyne is also unsaturated. And the general formula is CnH2n-2, meaning the amount of hydrogen is 2 less than double than the amount of carbon. Let's figure out the name of this hydrocarbon. First of all, why is it a hydrocarbon? Because I only see hydrogen and carbons. I should use reference table Q to figure out what type of hydrocarbon this is. But before we get started, we should count the number of carbons and hydrogens in this given compound. In this formula, I counted 5 carbons and 12 hydrogens. Before I name it, I have to figure out if it's alkane, alkene, or alkyne. Easiest way to figure out alkane, alkene, or alkyne by looking at a formula is by focusing on alkene, where the amount of hydrogen is exactly double than the amount of carbon. It is exactly double. Where if you look at alkane, the amount of hydrogen is more than double than the amount of carbon. And if you look at alkyne, the amount of hydrogen is less than double than the amount of carbon. So always look for the amount of hydrogen and compare it to the amount of carbon. If it's exactly double, then it is alkene. If it's more than double, then it is alkane. If it's less than double, then it is alkyne. So going back to our original question, here I have C5H12. So I have 12 hydrogens compared to 5 carbon. And the number of hydrogen is more than double than the number of carbon. And therefore, the general formula that fits this chemical formula is CnH2n plus 2, where n is equals to 5. So if you have C5, then H should be 5 times 2 plus 2, which is C5H12. Why is it important for us to figure out the general formula? It is important because if I know the general formula, which is CnH2n plus 2, then I would know the suffix of this organic compound. I know that the amount of hydrogen is more than double, and therefore the name should end with ANE, and it's an alkane. So now I know that the name would end with ANE because it is an alkane. And then I have to look at the number of carbon. So here I have 5 carbons. Therefore, I need a prefix for this organic compound. I'll go back to my reference table P for prefixes, and I would realize that for 5 carbon, the prefix should be pent. And now I can go back to the question and I can write that the name of this hydrocarbon should be pentane. And again, how did I get pentane? I used table Q to figure out if it's alkane, alkene, or alkyne. And I used reference table P to figure out the prefix. And this is what we need to do. So every time we're given a question to name a hydrocarbon, we have to use reference table Q to figure out the type of hydrocarbon it is, and then we can use reference table P to identify the prefix for that organic hydrocarbon. Let's try the second one. We have C2H4. So first, we should use reference table Q to figure out the general formula for this compound. Over here, I realized that the amount of hydrogen is exactly double than the amount of carbon. 4 is exactly double than 2. And therefore, if I look at reference table Q, the suffix should be ene. This is an alkene, where we usually see the amount of hydrogen is exactly double than the amount of carbon. Therefore, the name should end with ene based on the information that we got from reference table Q. But how many carbons do we have? Since we have 2 carbons, I have to use reference table P to figure out the prefix for this organic hydrocarbon. Since I have 2 carbons in total, the prefix would be -ate. Therefore, the name should be ethene. Again, always use reference table Q and P to identify the name of the given hydrocarbon. Why don't we try the third one? And once you're done, take a look at the answer and check your understanding. So, based on reference table Q, if we have a chemical formula of C2H2, then the number of hydrogen is less than double than the number of carbon. And we know that by using reference table Q, if it's less than double, then the suffix is going to be YNE. And therefore, we have to end the name with YNE. But if you look at the prefix, there are only 2 carbons, and therefore the prefix should be -ate. And if we combine those two together, the complete name is going to be ethyne. You should practice naming these hydrocarbons by pausing the video, and once you're done, please check your understanding. So the first one is ethene. The second one is different than the examples that we have done before. It's propane because we have more than double amount of hydrogens compared to carbon. And the prefix was prop because we have 3 carbons. And then the third one is something that we did in our previous slide, which is ethyne.